Okay, hi, Assalamualaikum everyone. So today I'll show you how to construct a frequency distribution table from this set of data. Okay, before we construct a frequency distribution table, we must know or we must determine the range of the data, the number of class for our table, and then the size of class. So for the first step, we must determine the range of the data. Okay, this is the formula to find the range. Okay, range is the highest value in the set of data minus the lowest value in the set of data. So from this set of data, we can see that the highest value is 20. So we write 20 and then minus the lowest value in this data is 9. Okay, 9, the lowest value. So 20 minus 9 is equal to 11. So 11 is the range of our data. Okay, for the next step, step 2, we must determine the number of class. Okay, this is the formula to find the number of class, which is equal to 1 plus 3.33 log n, where n is the total number of our data. Okay, this formula, we call it as Sturge's formula. Okay, to determine the number of class. So we have 1 plus 3.33 and then log. Okay, n is the total number in our data. Okay, so we have 1, 2, 3, 4, 5 and 6 columns, and then 1, 2, 3, 4 rows. So 6 times 4 is 24. So our n, our total data is 24. Okay, so we calculate with our calculator. So we have 1 plus 3.33 log 24 is equal to 5.6. Okay, so 5.6. Okay, number of class cannot be in decimal point. We must have a whole number for number of class. So if we get the number is in decimal point, we must rounding off that number. Okay, so 5.6, if we rounding off 5.6 is equal to 6. So number of class for our data is 6. Okay, now for the third step, we must determine the size of class. Okay, the formula to find the size of class is range divided by number of class. Okay, range, we already get the the value of range is 11 from step 1. So 11 divided by number of class is from step 2. So our number of class is 6. Okay, so 11 divide by 6 is equal to 1.83. Okay, so size of class is the same as number of class. We cannot have the number of size of class in decimal point. It must be the whole number. Okay, so for number of class, we must rounding off that value. But for the size of class, we must take the maximum number. Okay, so take the maximum number for this data. We have 1.83, so the maximum number is 2, not 1. So 1.83 is in between 1 and 2. So let me show the line number. So we have 1 and then we have 2. So 1.83 lies in here, in between 1 and 2. So we must take the maximum number. Okay, so our size of class is 2. Okay, for example, if you calculate the number of class, and then you get the number, for example, you get the number is equal to 1.37. Okay, so 1.37 lies between 1 and 2. So somewhere here, 1.37, in between 1 and 2. So for the size of class, we must take the maximum number. Therefore, the size of class is 2. Okay. So I repeat, for number of class, you rounding off the number. Okay, for example, if you get number of class, when you calculate, you get 5.3. Therefore, your rounding of 5.3 is equal to 5. Okay, for this data, we get 5.6. So we rounding 5.6, we get 6 for the number of class. Okay, for the size of class, we must take the maximum number. Okay, so for our data, we already calculate and then we get 1.83. So the maximum number for 1.83 is 2. Alright. Okay, now since we already have all the information to construct a frequency distribution table, we have range for the data is 11, and then we have number of class is 6, and then size of class is 2. Okay, so we can construct our frequency distribution table. So we have 2 columns here. Okay, the first column, we can just write the class. Okay, or depends on the questions. Okay, and then for the second column, we can write it as frequency. Okay, so class, how do we know how many classes that we have here? Okay, so as you can see, I have 1, 2, 3, 4, 5, 6 classes. 6 rows for class. Okay, so we can know the number of class from step 2. Okay, determine the number of class. So we already calculate, so the number of class for our data is 6. So that's why we have 6 classes here. Okay, and then we must write the first class. Okay, the first class must start from the lowest value. So the lowest value we can see from our first step. Okay, the lowest value is 9. Okay, 9 until, okay, how do we know 9 until what number? So we can see from step 3, determine the size of class. So our size of class is 2. Okay, so 9 we can calculate manually by using our fingers. Okay, so we have 9, starts from 9. Okay, so 9, 10. Okay, our size of class is 2, so just 9 and 10. Okay, So our first class is from 9 to 10. Okay, or if you want to use the calculator, okay, for example, our size of class here is 2, just a small number, so we can use manually, we can use our finger to know the highest value, to know the the highest value of our class. Okay, let's say if our size of class is 50. Okay, so it is easiest for us to calculate by using calculator. Okay, for example, our lowest value is 9, and then our size of class is 50. So from 9 we can plus the size of class 50, and then we must minus with 1. This is the formula, okay, to get the class. Okay, so from 9, the lowest value is 9, plus with the size of class 50, and then minus with 1, so 58. Okay, so let's go back to our question. Okay, if we want to use the calculator, so 9 plus our size of class is 2, and then we must minus with 1, so we get 9 until 10. Okay, so for the next class, okay, the upper value for the first class is 10, so for the second class we starts with 11 until, okay, we can calculate manually, so 11 and 12. Or if you want to use the calculator, 11 plus the size of class is 2, and then minus 1, so we get 12. Okay, so for the next class, this one is 12. Okay, and then next class, the lower value of next class is 13, so 13 until 14, and then 15 until 16, and the next class 17 until 18, and the last class is 19 until 20. Okay, so the last value or the upper value for the last class is not necessarily our highest value. Okay, for the lower value of the first class, 9, must be the lowest value in the data, 9. But the upper value of the last class, 20, is not necessarily equal to the highest value of the data. Okay, for example, if you get the last class, okay, if you get the last class is equal to 19 to 22, for example, okay, for example, our last class is 19 until 22, and our highest value is 20, so it's okay. Okay, no problem. The important thing is our highest value must included in the last class. So our highest value is 20, so it must be included in the class of 19 until 22. Okay, so this is just the example. Okay, now back to our question. So this is our class. Okay, we have 6 classes, and then we must fill up the frequency for each class. Okay, so for class of 9 to 10, we must refer our raw data. So we must check one by one from 9 to 10. So we have 10, 10, Okay, sorry. Okay, so we must fill up the frequency for the first class 9 to 10. So from this raw data we have 1, 2, 9 to 10, okay, 3, 4, 5, 6. Okay, so we have 6 data from 9 to 10. Okay, so we repeat the same process for the second class 11 to 12. So 11 to 12 we have 1, 2, 3, 4, 5 and 6. So 11 to 12 is also 6. And then for the third class 13 to 14. Okay, 13 to 14, so we have 1, 2 and 3. Okay, and for class 15 to 16, 1, 2, 3, 4, 5, 6 and 7. Okay, and for the second last class 17 until 18. Okay, 17 until 18, we only have one number, 17. And for the last class 19 to 20, 21. Okay, so one only. Okay, so when we already get all the frequencies here, okay, to be safe, try calculate the total number of frequency. So we have 6 plus 6 plus 3 plus 7 plus 1 plus 1. So we get the total frequency is 24. Okay, so our end from the second step just now is also 24. Okay, so this is our frequency distribution table for this set of data. Okay, so that's all from me. Thank you for listening and thank you for watching. Okay, Assalamualaikum.